students, you all are welcome to the physics class. Today we will discuss about another topic, which is projectile motion. What do we mean by projectile motion? To understand this, first we need to understand the difference between a linear motion and a motion in a plane. See, my dear students, when a body is moving with an acceleration whose direction is parallel to the direction of initial velocity. Remember the condition. A body moving with an acceleration whose direction is parallel with the direction of initial velocity, then what happens? With the time, the magnitude changes, but the directions remain same. This kind of velocity is along a straight line. Means if you throw a ball upward, if you leave some object from a high downward direction, these are one-dimensional motion, means motion along a straight line. Now, if the acceleration is in a different direction with the initial velocity, then what happens? With time, magnitude as well as the directions both change. So as both are changing, this motion is known as a motion in a plane, and the best example of a motion in a plane is projectile motion. See what happens if you throw an object with a horizontal velocity initially. So under the acceleration due to gravity, it changes to a curved path. Means except vertical motion, if you do not leave it from with initial velocity 0, if you leave it, it will fall downward. But with a small horizontal velocity, if you throw some object, then acceleration due to gravity g will continuously act upon it, and as a result of that, the body will take a curved path like this. So initially, suppose this is the horizontal velocity with which you have thrown, and let that be v1. So acceleration due to gravity acts here, and suppose at any arbitrary point here, how to find out the velocity here? The tangent at this point gives you the velocity. So suppose that is v2, the velocity here, and the acceleration due to gravity acts downward in this direction. So now see, if I want to find out the change in velocity delta v, so what I have to do? So this is v1 and this is v2. So basically this is delta v. So if this is v1 and this is v2, so this delta v will be v2 minus v1. Okay, v2 minus v1. But the direction of delta v, you can see the direction of delta v is same with the g. So delta v is also acting in this direction, and as well as the acceleration due to gravity also acts in same direction. That's why it doesn't change the horizontal range. Means from a same point, if you leave an object in downward direction, and if you throw it like this, they both will fall in the ground at the same time, but at different places. Means from a certain height, at the same time, if you leave an object, if you leave the object, it will fall downward, and if you throw an object with a certain small velocity, then what will happen? Both these objects will fall on the ground at the same time, but at different places. Okay. So this is the concept of projectile motion. And example of projectile motion, like a bullet fired from a gun, or a cricket ball after being hit by a bat, or when you throw a stone in the air. These examples are projectile motion. Now let us discuss about how the projectile motion works. Means what are the equations and how it is being calculated. See, for this I have taken here a diagram. Suppose this is the point of projection O. Okay. And remember one thing, the path which is followed by the this is called projectile which is going through, and the path which is followed by the projectile is known as trajectory. So suppose O is the point of projection from where an object is thrown with an initial velocity u0 and making an angle theta with the horizontal axis OX, and OY is the vertical axis. So this initial velocity u0, so there are two components of the velocity. One is horizontal component, which is written as ux, which will be, I know, u0 cos theta, let it be theta. Okay. If you want to take it theta 0, you can also make it theta 0 initially. So this becomes u0 cos theta 0, and the horizontal component of the velocity you get as u0 sine theta 0. From vector we have learned this. So this is the horizontal component of the velocity, initial velocity u0, and this is the vertical component. So this is the uy and this is ux. Now what happens during the motion? Ux remains unchanged. Horizontal motion remains unchanged, provided there is negligible resistance of air. This remains unchanged throughout the motion, but with the height, this uy it changes. And while uy changes slowly, and when it reaches the peak point, here the vertical velocity, that is uy, it becomes 0. So here at point P, the vertical velocity of the object is 0 because it has gone to the peak. Now it will come down. So again it will increase slowly. So from this, ux equals to u. Now suppose, so at time t, at small time t, suppose x is the horizontal distance which is covered by the object. The object which you have thrown, it will cover some vertical distance as well as some horizontal distance. I am considering that in small time, at time t, it has covered a distance x, horizontal distance x. So how to get the value of x? So the horizontal velocity ux into time, velocity into time. So ux means u0 cos theta 0 into t. So from this you may get the value of t as x by u0 cos theta 0. This is the expression of time. Now, what is the vertical height that has been covered by the object in that same time interval t? So I will use this equation h equals to ut minus half gt square. Now, what will be the value of u here? As I am talking about vertical, so I will take the uy here. So here will be uy into t. So this expression becomes h equals to, so suppose h means y. It is traveling y distance. It is covering y height vertically. So y can be written as, so in place of uy I have to write u0 sine theta 0 into t. So in place of t I will put this value x by u0 cos theta 0 minus half gt square. So half into g into t square means I will put the value of t here. So x by u0 cos theta 0 whole square. Fine. So what is the expression we are getting? See, these are being cancelled out as they are not equal to 0. So I get at this is x into tan theta 0 minus half into g into x square by u0 square cos square theta 0. Now as you can see the expression, this is quadratic in x and linear in y. This equation is quadratic in x and linear in y. So this denotes a parabola. That means the path of the projectile or the trajectory is parabolic. Okay, so from here we can prove that the path is parabolic. Next, we will try to find out some terms related with the projectile motion. And to start with, we will first try to find out the term which is known as time of flight. Means the time taken by the object from where it has started and when again it has come to the ground. Means from here OP, and suppose this is O prime. So the time taken by the object to start from O and to reach O prime, that is known as time of flight. So we will try to calculate that. Well, time of flight, so first we will try with this. From O to P, motion from O to P, because this is, now remember this one, the time taken by an object from reaching from O to P and the time taken by the object from coming down P to O is same. Means same time is taken from O to P and P to O prime. To start with, so this is the equation we will be using, V equals to U minus GT. Now at point P, velocity. So vertical velocity I am considering. So v equals to vy, y component means vertical component, which is 0 at point P, and u will be using the y component because I am considering the vertical velocity here both. That is u0 sine theta 0. So from this equation, 0 equals to u0 sine theta 0 minus gt. So time we get as u0 sine theta 0 by g. Okay. So from this we are getting the time which is being taken by the object from going from O to P. Now as I said, the same time is being taken from coming down P to O prime. So the total time of flight how do you get? Suppose that is capital T. So that will be 2 into T. 2 times of that. So it comes as 2 u0 sine theta 0 by g. This is the expression for time of flight. This is time of flight. I hope this is clear to you. Next topic, means next term, which is related with the projectile motion, is the maximum height which is reached, the vertical height which can be reached by the object starting with the initial velocity u0. For this, we will be using this equation, v square equals to u square minus 2gh. Again, same condition you have to put, where v equals to vy means vertical velocity I have to consider. So there the vertical component of the velocity is 0, and similarly there is only the horizontal component of velocity, which is this so u0 sine theta 0 here. Okay, now if I put the value here, what we will get? But in order to get this, so put the value here. So 0 square equals to, now put this u0 sine theta 0 whole square minus 2 into g into h. So from this h we get as u0 square sine square theta 0 by 2g. So this is the expression of maximum height which can be reached by the object. Now from that expression, you see, notice one thing, the value of this expression will be maximum, the value which we have got, that is h equals to u0 square sine square theta 0 by 2g. The value of this expression will be maximum when this theta 0 will be 90 degree. So if this theta 0 becomes 90 degree, the maximum height can be reached, and which comes as u0 square by 2g. That means if you throw an object vertically upward, it will reach maximum distance. That's why athletes who are taking high jump, they try to throw their body upward, vertically upward, so that they can reach the height. So this is the maximum height which can be reached by an object which is being thrown with an initial velocity u0, and g is the acceleration due to gravity. Next, the third term is the horizontal range. So vertical range we have got, time of flight we have got. Now we will talk about vertical range. So next is vertical range. Sorry, horizontal range. Which is denoted by R here, as you can see, from O to O prime. This is R. This is the horizontal range, means horizontal distance traveled. So R simple as that. Ux, the horizontal component of the velocity, into total time of flight, total time taken from going from O to O prime. So put the values now. U0 cos theta 0, and you have to put the value of the expression. If you remember, we have got the time of flight t as u0 sin theta 0 by g. Okay, this is the time of flight. So there was a term 2u0 into sin theta 0. So if you multiply this, what you are getting? 2u0 square sin theta 0 cos theta 0 by z. So now 2 sin theta cos theta means sin 2 theta, so I can write this like this: u0 square sin 2 theta 0 by g. This is the value. So the horizontal range is coming this. Now when this horizontal range will be maximum? When this value will become 1. Maximum value of sin theta is 1. So according to the condition, if you want to get maximum horizontal range, the value of this sin 2 theta 0 has to be 1. And this only happens when it is 90 degree. So comparing both, we get 2 theta 0 equals to 90 degree. So we get as theta 0 equals to 45 degree. That means if you want to cover the maximum horizontal distance, you have to throw the object at an angle 45 degree with the horizontal. If you want to throw it maximum, if you are fielding in a cricket field, and if you want to throw a ball to maximum distance horizontal, then you have to throw it at an angle 45 degree. Now what happens? Let me explain you here. So the maximum, if it is 45 degree, then maximum horizontal range will be u0 square by g. This is the maximum horizontal range. Well, now let me show you one interesting fact regarding this projectile motion. One object is being thrown at an angle 60 degree. Okay, one at 45 degree and one at 30 degree. What happens? This 45 degree one goes here horizontal, 60 degree comes here, and also the 30 degree comes here. If you take the horizontal, what happens here actually? See, the expression which you have got, if you remember, in that, if you put 90 minus theta in place of theta, in case of horizontal range, in place of theta, if you put 90 minus theta, the value will come same. That means whether it is 30 degree or 90 minus 30, that is 60 degree, horizontal range will not change. They are same for 30 and 60. Maximum for 45, but they are same for 30 and 60. And the fact is that for 60 degree, it will be, it will be more time in air. It will be more time. It will fly more time in air than which is projected at an angle 30 degree. But they will reach the same horizontal distance. They will cover the same horizontal distance. But one will be, one will take more time here. So that's why I told you. Remember that vertically if you drop one drop here, vertically if you drop this, and if you leave it here, so they will reach the same point, but on same ground at the same time, but at different places. Horizontal ranges will be different. But remember here, whether it is theta or 90 minus theta, the horizontal ranges are same. Only the thing is that when the angle is more, it will cover more time. It will take more time to come to the ground. Okay, it will be more time in the air. Rest are same. So this is it for the projectile motion. Thank you.